Welcome to lecture on engineering materials and metallurgy. So today's topic is solid solution. So let us have some introduction about this subject. So in broad classification, when you say as an engineering materials, we have metals and non-metals. So under the metals category, you have ferrous and non-ferrous. Under ferrous, you have an iron, steel, and etc. Under non-ferrous category, there is no that is the least quantity of iron may be present. So in that category, aluminum, copper, lead, silver, tin, and zinc. Under non-metal, so you have polymer and ceramics. Under polymers, you have thermosetting and thermoplastics. Then under that, different categories are there. Under ceramics, you have refractories, abrasives, glass, cement, as well as concrete. So material engineer work with metals, ceramics, plastics to create new materials. Materials engineers develop, process and test materials used to create a range of products from computer chips and aircraft wings to golf clubs and biomedical devices. So as I said earlier, so metallic, polymeric, ceramic, composites, the electronic materials are the five main classes, so which is widely practiced. Metals can be considered most important engineering materials. Metallic materials are pure metals, or it may be alloys, which may be composed of one or two or more metals. How can we compare materials? First is based on performance, second one is properties. So there are definition of different thing like hardness. So it's one of the important mechanical property. Then toughness, stiffness, like that different properties. Based on that, the materials are selected. So elastic, plastic, strong, brittle, all those things are considered. It's melting point, boiling point, all those things. Composition tells what chemicals are in the samples. The most specific description will reveal chemical elements are present in the sample. Compound has a uniform composition. Every sample removed and tested, no matter how small, contains same element in the same properties. But in mixer, then the different elements are not coordinated with each other. Samples from mixer won't always have identical properties. Synthesis implies a major change in composition. For example, polymers are synthesized by cooking mixture of chemicals. New molecular structures result. Valence electrons. Chemical properties of an element are determined by number of electrons available for reactions. Ion is a particle for which number of protons is not equal to number of electrons. An alloy is a combination of metal or metals combined with one or more other elements. Alloys are usually produced by melting the mixture of ingredients. Following phases may be present in metals in solid state. One is solid solution, second one is intermetallic compound. Phase is a state of matter that is uniform throughout in chemical composition and physical state. Solid solution. When in solid, the atom solute are present in lattice of solvent. It is known as solid solution. A solid solution is formed when two metals are completely soluble in liquid state and also completely soluble in solid state. In other words, when homogeneous mixtures of two or more kind of atoms occur in solid state, they are also known as solid solution. Intermetallic compound, a compound formed by two or more metals such as aluminum and lithium composed of two or more metals of metal and or metal and non-metal. So alloy is also referred as a solid solution or random mixture of metals in which elemental crystal structure of one of the constituent element is adopted. The intermetallic compounds, a defined stoichiometry and crystal structure with specific size assigned for atoms of each constituent element. There are two types of solid solution. One is substitutional solid solution. Second is interstitial solid solution. In a substitutional solid solution, when the atoms of solute substitute for atoms of solvent in its lattice, it is known as substitutional solid solution. Here you can see that. So all are solvent atoms, that is, assume all are green atoms are solvent. If it is substituted by a solute atom, blue color, then it is called substitutional solid solution. In the atoms of solute substitute for atoms of solvent in the lattice, the solution is known as substitutional solid solution. The solute may incorporate into solvent crystal lattice substitutionally by replacing a solvent particle in the lattice. The atoms of the solvent or parent metal are replaced in the crystal lattice by atoms of solute metal. Then the solution is known as substitutional solid solution. So in this two types, ordered solid solution, disordered solid solution. So next one is interstitial solid solution. When the atoms of solute occupy the interstitial spaces in the lattice of the solvent, it is known as interstitial solid solution. The size of the solute is less than 40% of the solvent. Interstitial solid solution may be formed. Here you can see that. Here the atom size is less, it goes and occupies the space in between the solvent atom. Solute atom and the solute atoms occupy space in between the solvent atom. It is known as interstitial solid solution. There are two set of rules, one which refers to substitutional solid solution, another refers to interstitial solid solution. For so interstitial solid solution, solute atoms must be smaller than the interstitial sites in the solvent lattice. Solute and solvent should have similar electronegativity. For substitutional solid solution, the atomic radii of solute and solvent atoms must differ by not more than 15%. The crystal structure of solute and solvent must match. The solute and solvents should have similar electronegativity. Thank you for watching.